This video is one of a series covering the released Ohio State math questions between 2017 and 2023. Expressions and equations make 1/3 of the test questions. Graph proportional relationships, interpreting the unit rate as the slope of the graph. Compare two different proportional relationships represented in different ways. For example, compare a distance-time graph to a distance-time equation to determine which of two moving objects has greater speed.
Hello and welcome. Let's see what we need for today. Proportion is an important topic, extremely important, used in many ways. Two ratios, fractions, form a proportion if they are equivalent. So let's see if these two ratios, 16 to 36 and 20 to 45, form a proportion. There's two ways of doing it. The first way is to simplify the fractions. So if you simplify 16 over 36, you get 4 over 9. And if you simplify 20 over 45, you get 4 over 9, and both are equal, so they form a proportion. Another way of doing it, which I really like and I use quite a bit, is called cross multiplication. In this way, you put the two fractions and you multiply 36 times 20, you get 720. You multiply 16 times 45 and you get 720, and they are equal, and therefore they form a proportion. Another example, let's see if 14 over 10 and 21 over 15 form a proportion. Same way. Simplify 14 over 10, you get 7 over 5. Simplify 21 over 15, you get 7 over 5, and they are equal, and they form a proportion. The cross multiplication method, you multiply 14 times 15, and you multiply 10 times 21. You get 210 and 210, and therefore they form a proportion. This example, let's see if 5 over 10 and 6 over 18, we will show that they do not form a proportion. Why? Look at the ratios. 5 over 10 is 1/2, and 6 over 18 is 1/3, and 1/2 is not equal to 1/3. If you use the cross multiplication, you said 5 times 18 is 90, 6 times 10 is 60, and they are not equal. The ratios 7 to 16 and 5 to 9 do not form a proportion. Simplification method, there's nothing to simplify. Therefore, you really need to use the cross multiplication. 5 times 9, 63. 16 times 5 is 80, and those are not equal, and therefore they do not form a proportion. A proportional relationship, sometimes referred to as direct relationship between two variables x and y, is proportional if the ratio y to x is always the same, does not change. So y to x is constant. K is a constant, and we consider k as a positive. So y would be equal to kx. K is a constant, k is greater than 0. If this is the equation of a line with slope k and passes through the origin, k is called the constant of proportionality. If a relationship is represented by a line, the line must pass by the origin for the relationship to be proportional. And we will talk about this a little bit later. So does the table, now let's see a proportional relationship using tables. Does the table shown represent a proportional relationship? So see, we need to do y over x. 4 over 1, is it equal to 12 over 3? Yes. Is it equal to 20 over 5? Yes. They all equal 4. So it does represent a proportional relationship. In this situation, the equation is y is equal to 4x. So when x is 1, y is 4. When x is 2, 3 here, 3 times 4 is 12, 5 times 4 is 20. So 4 is the constant of proportionality. Does the table shown represent a proportional relationship? Okay, 4 over 2 is 2, 6 over 3 is also 2, that's good so far, 10 over 5 is 2, but 15 over 7 is not 2. So this does not represent a proportional relationship. Now, proportional relationship using graphs. Pay attention to this. A graph to represent a proportional relationship must satisfy two conditions. First, it should be a straight line, linear. Second, it should passes through the origin, meaning the point 0, 0 is on the line. Here's an example of a graph that represents a proportional relationship. It's a straight line, it passes through the origin. This one is not a proportional relationship because it doesn't pass by the origin, even though it's linear, but it doesn't pass by this point here. This one is also not a proportional relationship, although it passes through the origin, but it's not straight line. It's not straight line, so that does not work. Now let's go to the questions, the examples. A grocery store sells 2 pounds of apples for $4. We need to draw this. Use the add arrow tool to graph the relationship between the cost of apples and their weight. So when you look at this 2 pounds you buy for $4, so 4 pounds would be $8. So 2 pounds is $4. Take another point now, 4 pounds is $8. Now if you want to take 6 pounds, it would be $12. So if you take 1 pound, it will be $2. And then you just draw a line through them, and that would be your answer. So any graph with 2 points on the line is an answer. So that's how you draw it. It's straightforward. Question number 2. Roderick can water his lawn with a small hose or a large hose. The small hose pumps 15 gallons of water per minute. The large hose pumps water at twice the rate of the small hose. Use the add arrow tool to show the relationship between time and the gallons of water pumped by the large hose. Okay, here's how you set it up. Small hose, what do we have? It's 15 gallons per minute. So your equation is y is equal to 15x. 1 minute, 15 gallons. 2 minutes, 30 gallons. The large hose, you need to pay attention to this word here. Twice. So it should be y equal 30x. 30x. So now they want you to draw this. So to draw a line, you take 2 points, and be careful, take 2 points. If I take 0, 0, if I take the point 0, x0, y0, if I take x1, y would be 30. So these 2 points are on the line. So I draw these 2 points, 0, 0, and 1, 30. If you want to take a third point, that's fine. And you get the line representing this situation. Example number 3, a company has an old laser printer that prints pages at a constant rate as shown on the graph. The company buys a new laser printer that prints the same number of pages in 1/3 as much time as its old printer. So that's three times faster. Use the add arrow tool to graph the relationship between the number of pages printed and time for the new printer. So they were nice enough to give you this point here as a hint for you. So look at this graph, try to understand what's happening here. That's the laser, that's the old That's the old printer. 20 seconds, it prints 6 pages in 20 seconds. 6 pages in 20 seconds. So, solution, old printer, 6 pages in 20 seconds. Where did I get that from? From the graph right here. The new printer, it's 1/3 as much time as its old printer. So which means 6 pages will be done 20/3 seconds, 1/3 of the time. So if you multiply this by 3, you get 18 pages in 20 seconds. So in 20 seconds, 18 pages, right here. 20 seconds, 18 pages, and you draw a line through 0 and this point, and you are in good shape here. Now, notice that the old printer, the slope is 6/20. The new printer, the slope is 18/20, which is 3 times more. So notice slope of the line for the old printer is 6/20. Slope of the line of the new printer is 3 times 6/20 is 18/20. Example number 4. Here we are comparing a table, a graph, and a formula, a function here. So two companies manufacture pens. The number of pens Y company Q produces in X hours can be modeled by the equation shown. The number of pens company R produces per hour can be modeled by the graph shown. So this should tell you what is happening. Here, for instance, in one hour, it produces 250 pens. 2 hours, 500. Here, in 2 hours, in 3 hours, 600. So they were nice enough to give you this point here as a hint. 3 hours, 600. So let's see how we can set it up. Company Q, that's the equation. X is 8. They want this to be for 8 hours, okay? Based on the models, what is the difference? The difference, be careful about this word, between the number of pens company Q produces in 8 hours and the number of pens company R produces in 8 hours. In 8 hours, so we put 8 here instead of this X, 250 times 8, that will be 2,000 pens. Company R, X, when X is 3, Y is 600, that's given. Now my X is 8. I don't know how much is this. I put an N here. I didn't use X because I don't want you to confuse it with this X. Cross multiplication, that's what I like about cross multiplication. So N will be 8 times 600 divided by 3. It will be 1600. So we're not done yet. Don't put answer 1600 or 2000. They want what? The difference. So the difference is 400. You get 400 here and you get the answer. Now, if you want, you can look at the company R and say R produces 600 pens in 3 hours. 600 pens in 3 hours. So 200 in 1 hour. In 8 hours is 1600. Thus you get the same answer as here. Example number 5. This is a little bit kind of lengthy here. A teacher compares the masses of 2 samples of different liquids. The equation M is equal to 0.674 V models the mass M in grams G of liquid ammonia. The variable V is the volume in milliliters. The graph shown represent the relationship between mass and volume for hydrogen peroxide. So here you are again comparing a formula, an equation, with a graph. So what they want here, the teacher compares the masses of 10 milliliters samples for each liquid. And here it says select words or phrases to complete the statement to describe which sample of liquid has a greater mass. Okay, and they wanted to fill this up. So let's see how we can understand this. The ammonia the mass is 0.674 V. Okay, so when V is 10, you get 6.74. You multiply this by 10. Now the hydrogen, the mass is, if you look at this here, is almost 10 for 10 here. It's not quite. So you the mass is almost 1 V. So when V is 10, the mass will be around 10. And obviously this is much bigger than this. So the answer will be the hydrogen peroxide has greater what? Unit rate. The unit rate here is 1. The unit rate here is 0.674. Example number 6, the graph models the amount of money Haley is paid Y in dollars for working X hours at the job. So you look at that here, and see, there's here the word estimate, which means it's not going to be an accurate answer, an estimation. So what happened is, if you look at the graph, you are tempted to say that 110 is on the graph or close to the graph, and you would answer $10 per hour, and that is not right. That is wrong, because look what happened as the number of hours increases. Look at 3. At 3, you don't have 30. Look at 4. You don't have 40. You have much more than 40, see? So that's not a good answer. But what happened to this line is if you compare it with y equals 10x, it's going further away, farther away. So a good estimate will be when it would be this point. When 5 hours, $60. So 60 divided by 5, that's $12 an hour. And any answer between 11 and 12 would be acceptable. Example number 7, Marisol, Timothy, and Zorian each have a machine that purifies water. The two tables show how much purified water Marisol's and Timothy's machines have produced at certain times after pouring water into the machine. So you have two tables here, gives you the relationship between time and the number of water purified in ounces. And Zorian's machine produces purified water at a constant rate that is faster than the rate for Marisol's machine and slower than the rate for Timothy's machine. And then they're asking you what equation could represent the amount of purified water Y in ounces that Zorian's system produces after X hours. Okay, so let's see what happens. We need to find the rates here. Marisol's machine, the rate is, you take 2.2, this point and this point, so 18 minus 12 divided by 3 minus 2, it gives you 6 ounces per hour. You can use, if you want 30 minus 18 is 12, divided by 5 minus 3 is 2, you get the same answer, 6. So we do this, which means the equation here is y equals 6x. And then you can double check it. When x is 2, 2 times 6 is 12. Check it for 8. When x is 8, 6 times 8 is 48. We're for sure we are good. This one here, we do the same thing. 54 minus 36 divided by 6 minus 4. You get 9 ounces an hour, and the equation will be y equals 9x. You can check it out. When x is 4, 4 times 9 is 36. When x is 9, 9 times 9 is 81. We're all good so far. Now I need to go to see the question here. Zorian's machine, faster than Marisol's and slower than Timothy's. So the rate is slower than Timothy, slower than 9, and greater than 6. Between 6 and 9, if you look at the questions, the possible answer they're giving you, that's the only answer that would do the job. So y equals 8x. And that's it.
Thank you for watching. If you would like to have a copy of the PowerPoint presentation, please leave your email address in the comments section, and we will be happy to email you a copy.
Thank you and see you soon.
Thank you for watching. More videos to come. Please subscribe.